Software engineering used to run at the speed of human typing. Every feature required exhaustive, static specifications, translated line by tedious line into syntax. Humans were the primary bottleneck. Now, you simply state a business outcome. Autonomous agents take that intent and instantly architect, test, and deploy the application. This is intent-driven development. Instead of trying to predict every technical detail upfront, human developers provide the problem and the boundaries. The AI system then builds iteratively, learning and discovering the exact solution as it writes the code. Because the code evolves so rapidly during this process, traditional requirements fail. Teams rely on build-first documentation, recording the reality of the software after the AI builds it, rather than writing obsolete specs beforehand. Removing the manual typing bottleneck accelerates delivery, but having software write its own updates creates new failure modes. To maintain safety, we have to move away from individual prompts and toward a multi-agent control structure. To control this process, modern enterprise AI doesn't rely on a single monolithic language model. It utilizes a highly structured organization of specialized agents, each assigned distinct roles within a shared framework. The process starts with a planner agent. It maps the legacy codebase, ensuring that any new features align with the existing architecture and avoid breaking older systems. Once the plan is set, a coder agent generates the actual code patches, operating strictly within the overarching roadmap the planner provided. This diagram outlines the precise handoff. We see the flow moving sequentially from planner to coder, then tester, each pulling context from shared vector memory. If the tester flags a failure inside the sandbox, the debugger steps in, using direct execution-grounded feedback to repair code until tests pass. Dividing tasks among these specialized roles and forcing them to prove their work in a sandbox prevents the AI from hallucinating. It allows the system to handle complex, long-horizon software evolution reliably. But letting AI iterate on its own code without boundaries is dangerous. When large language models continuously optimize, reformat, or extend a codebase, they inadvertently introduce what researchers call the security degradation paradox. Research shows that after just 5 cycles of unchecked AI code refinement, critical vulnerabilities jump by exactly 37.6%. Seemingly secure code rots as the machine tinkers with it. This flow diagram illustrates the solution, an iterative security gate. A hybrid analysis engine inspects code generation at every refinement cycle. The gate calculates a rigid confidence score. A failure triggers a block, sending the agent into a refine loop, or kicks the problem out to human intervention. We can see how this fits into the broader picture in this system design. The iterative security gates act as the core innovation, positioned in the middle of a massive 7-agent security framework that spans the entire software development lifecycle. These hard security checkpoints are the exact mechanism that transitions AI from a risky autocomplete novelty into a safe, enterprise-grade autonomous engine. Because these systems manage the complexity for you, you no longer need a massive team of engineers to build profitable software and digital platforms. TechView's 10x teaches entrepreneurs exactly how to harness these autonomous AI coding tools. You learn how to rapidly launch digital products and automate complex workflows from the ground up. Visit techviews10x.com right now to learn how to build high-margin revenue streams online. Zooming out to the broader economic impact, writing completely new programs is actually a small fraction of the job. Up to 80% of current software engineering is simply maintaining and evolving legacy systems. This diagram maps out that real-world maintenance cycle. Engineers analyze an existing system, identify required changes, gauge the impact, and execute an evolution process to produce an updated system. As multi-agent architectures automate these maintenance loops, the human software engineer transitions from a writer of code to a governor of systems. The focus of the job moves away from in-the-weeds manual labor. The human's role elevates to high-level oversight. The true bottlenecks in software development are no longer typing syntax. The friction points are now defining precise requirements, ensuring strict business alignment, and rigorous testing. The developers who win this decade will be orchestrators. They will excel at defining intent and managing continuous integration pipelines, rather than manually hunting for missing semicolons. Orchestration is the next technical frontier. Subscribe to the channel for more technical deep dives, and visit techviews10x.com to master these systems today.